Hello, I want to show you the best 5-minute video that I'm aware of in the realm that I work in, which is what is the role of biology in making our world habitable? So I want to show you this. It's a 5-minute video. I'm not going to show you the whole thing. I'm only going to show you part of the video for copyright reasons. And then I'm going to talk about some of the major points that it makes, but I want to introduce you to the video. So let's do that.
In temperatures and climate instability.
The name of this video is, it has two titles: How Plants Cool the Planet, and also How Plants Could Save Us. I think if you're searching for it, the best way to look for it is How Plants Cool the Planet.
In a time of rising temperatures and climate instability, most of the attention goes to greenhouse gases. But there is another way, often overlooked, to stabilize the climate and cool the planet: plants. Unlike high-tech geoengineering schemes, forests, wetlands, grasslands, and marine ecosystems bring numerous benefits beyond just cooling the atmosphere. They increase biodiversity, they can prevent floods, and prevent erosion. But for now, let's talk about how they stabilize the weather and promote cooling. We all know that plants drink water through their roots, but what happens to that water? Most of it comes out through the leaves as part of the process of photosynthesis. In fact, for each molecule of carbon dioxide fixed and each molecule of oxygen released, several hundred molecules of water are evaporated. This is what we call transpiration. And it cools the forest in the same way sweat cools the body, the evaporation absorbing the heat. That's why forests feel so cool. It isn't just the shade. On the edge of the Amazon rainforest, temperatures are consistently 5 degrees cooler than on farms just a short walk away. And in Sumatra, native...
Now, I wanted to show you that. I invite you to go see that. And for the remainder of the time, I'm just going to show you, let me see, stop screen. I got to do some gymnastics here. I'm going to present, share screen, and I'm going to click on that. How Plants Cool the Planet is the name of my slideshow. And I'm going to click on this view. Let me see, do this. Sorry, StreamYard makes you go through all these gyrations just to change the screen. So this slideshow highlights the main points of Jimmy Soul's video, How Plants Could Save Us, also known as How Plants Cool the Planet. So, there's the thumbnail and there's the link. I invite you to go watch it. Now, here, the remainder are just some of the main points in it. So point number one, trees and plants transpire water, cooling their surroundings as the water evaporates. This is very important. This has a big influence on our climate, and it has a bigger influence on our climate than is commonly given credit in the mainstream climate conversation, of which I'm not a fan. So if you talk about the mainstream climate conversation, let me click out of this and talk to you a minute. If you talk about the mainstream climate conversation, this is what we get from major media. This is what comes to us from the New York Times, NPR, PBS, the United Nations, Sierra Club, and all the media. They're just, climate change is the big story, the big environmental story of the last 50 years, and it's going to continue to be that way for some time. But what we're not told is that greenhouse gases are only part of the picture. So this is a really good video for showing how it's not just about greenhouse gases. And I wanted to share with you some of the main points. So trees and plants transpire water, cooling their surroundings as water evaporates. This has a tremendous cooling effect locally and regionally. And some scientists and other experts think that the effect is not just regional, but it's more global. As a result of the transpiration. So as a result, forests can measure 5 to 10 degrees Celsius, 9 to 18 degrees Fahrenheit cooler than adjacent clearings. This is a picture of a rainforest. The rainforest is transpiring water. Lots of water is evaporating from these trees as a result of that transpiration, which is the progress of water from the roots through the stems, out through the leaves, and then the evaporation occurs. That has a tremendous cooling effect, just the way it does when we sweat or perspire. We feel cold. If you get outside and you're exercising on a hot day and then a breeze comes along, the breeze feels cool because it's causing water to evaporate from our skin. And it's the same thing if you walk under a shade tree or into a forest. It's cool, not just because of the shade, but also because of the evaporating water. Next slide says bacteria living in trees move with water vapor into the atmosphere. So it's not just bacteria, but it's other things. But the trees exude bacteria and also volatile organic compounds that provide the nuclei that causes condensation. Water vapor cannot condense without a condensation nuclei, and trees provide some of that. They provide, 40%, somewhere between 40 and 60% of the rain that occurs on land occurs because of condensation nuclei from plants and trees. Water droplets cling to these bacteria. That's the condensation nuclei I've been telling you about. Water droplets cling to these bacteria, forming water droplets. Forests, grasslands, and marine ecosystems each form their own type of condensation nuclei. Item number 4, I'm going through about 10 to 12 points that figure prominently in this video, how plants could save us or how plants cool the planet. Number 5, when water vapor condenses to make rain, it releases heat. This is the reverse of the cooling effect that occurs during transpiration. So you have evaporation, which causes a cooling effect, but then that water vapor goes up to the clouds and then it condenses. And when it condenses, that heat reemerges, that heat reappears. And when that heat reappears, that goes hand in hand with a release of infrared radiation. So the infrared radiation is like on the light spectrum. It's actually below the light spectrum, but the light is electromagnetic radiation, so is infrared, and which means it goes out into space. It travels at the speed of light, quite literally, out into space. Item number 6, this release of heat that occurs in the upper atmosphere from where the heat radiates back into space, thus creating a cooling effect, which counteracts the greenhouse effect associated with climate change. So that release of heat out into space helps cool the planet. And here's a picture of a cloud. This release of heat occurs at the cloud level. And some of that when the condensation occurs, the infrared radiation goes in all directions. Some of it comes back down to the earth, but some of it goes out into space, and that is an important mechanism for cooling the planet. And we want this to be occurring as much as possible. Number 7, whenever forests are absent, and we're just randomly almost going through the points in this video, how plants could save us. Whenever forests are absent and therefore cannot contribute condensation nuclei, the water vapor forms a haze that heats the atmosphere because water is a greenhouse gas. So what we're saying here, I'm going to click out of this. What we're saying here is that the water vapor that evaporates. So trees and plants cause water vapor to evaporate. So the water vapor comes from trees and plants. It also comes from evaporation from the soil. It also comes from evaporation from bodies of water, such as rivers, lakes, and oceans. And it results in a lot of water vapor being in the atmosphere. So water vapor is a greenhouse gas. We would like, if we could, pretty please, we would like to reduce the amount of water vapor that is in the atmosphere because it's a greenhouse gas, because it causes warming. Also, all that water vapor in the atmosphere, we want it it's going to condense. It's going to condense sooner or later. We would rather it condense sooner, because the way to make it condense sooner is to involve are you ready for this? Biogenic condensation nuclei. So biogenic means the condensation nuclei that comes from plants and trees. It includes bacteria, volatile organic compounds, fungal spores, and pollen are all biogenic condensation nuclei. It can also come from phytoplankton. It can come from, photosynthetic. It can come from plants and plant-like things in the ocean. And so we want as much of that as possible. We want this biogenic condensation nuclei because it causes it to rain steady, gentle, consistent, instead of long dry spell and then a deluge, because there's so much water vapor up there, and because it comes down so occasionally, so rarely, and it only comes down when you've got salt or ice crystals that are doing the work of condensation. So that's a lot to take in. I'm kind of just riffing on this. I don't expect you, if this is new to you, I don't expect you to absorb all of what I've just said. The important thing is that we want as much of this condensation nuclei to come from plants and trees, instead of relying on salt and ice crystals, which means that it only rarely comes down, and when it rains, it pours. When it rains buckets. If you have, over a foot of rain, it's probably because the water vapor was stuck up there, and it's stuck up there because there's not enough of this biogenic, the right kinds of condensation nuclei. So let me share with you a couple more points, and then we'll wrap it up. But, this is just randomly going through the points you will find in this excellent video, which I'm encouraging you to go watch. It's the best 5 minutes you can spend as far as understanding what the climate really needs. And if we take care of what the climate really needs, we will also be taking care of what wildlife really needs. So intact ecosystem, number 8, intact ecosystems soak up rainfall and sink it into the soil, thus preventing the worst effects of climate change, including droughts and floods. We need intact ecosystems. We need to make space for intact ecosystems. We need to reduce all of the things that take up space, that prevent ecosystems from growing. That's another topic, but ecosystems require space. And we can take some of our farmland and convert it into regenerative agriculture, which means we are using it for ecosystem. It means that we can have a type of farming that is an ecosystem for wildlife. And if we do that, then we'll also be preventing flooding and drought. Flooding and drought. Number 9, intact ecosystems absorb water, dampening the kindling that will otherwise fuel wildfires. Number 10, plants consist mostly of carbon, so when they grow, they absorb carbon. We want space for these ecosystems so that that's what's going to solve the problem of climate change. Some people don't think climate change is a problem, others do. I think, a lot of people, I don't want to go into that, but, the whole point of this my video, the whole point of the video that I'm trying to introduce you to is that ecosystems will solve so many more of our problems if we will let them. So one or two more screens here. The purpose of this screen is to show how if you give water and carbon flow in the same direction. Water and carbon are always flowing into an ecosystem. Water and carbon are either flowing into it or out of it. They're doing both, but on a net basis, water is either flowing into the ecosystem or flowing out. And for water and carbon to flow into the ecosystem, they need plants. We need more plants. We need more living systems. Intact ecosystems consist of carbon, so when they grow, they absorb carbon from the atmosphere. And, the soil food web consists largely of carbon. So when we enrich the soil, we store carbon permanently until and unless we destroy that living system. And this is a picture of the soil food web, which is, a graphic representation of what is in a graphic representation of what is in quality soil. Protozoa, fungi, nematodes, bacteria, microarthropods are the 5 categories of living things that are in a healthy soil food web. We need this healthy soil food web for so many reasons, but not least of all that it helps absorb the rainfall, and thus it helps to support the water cycles that will help to stabilize our climate. So that's about all I have today. I wanted to share with you this excellent video. It has 2 titles: How Plants Could Save Us or How Plants Cool the Planet. And I wanted to share that with you because I want you to see this video. I've seen it many times. Every time I watch it, I absorb something a little different. It's just excellent. I wouldn't dedicate this video to showing you a video if it weren't an excellent video, very, very useful. It even has a lot of scientific research associated with it. And you can find that scientific research at the end of the video and in the show notes that go along with it on YouTube. That's about all I have. Thanks so much for joining me. Have a great day.